Great. Thank you so much for joining us today. I'm Phil Scully from Balerion Space Ventures. We're joined by Andy Phelps from SpaceNukes. Andy, thanks so much for joining today. A lot of people are very interested in nuclear and learning more about your background. Can you tell us kind of like your backstory and the backstory to SpaceNukes?
Sure. I'm a civil engineer, worked for a company called Bechtel, which I think many of you might know, for 46 years. I started working for them when I was 16 on the subway in DC as a laborer. And there's a longer story there, but they didn't want me to continue as a laborer and encouraged me to finish university. Got a bachelor's in civil engineering from Georgia Tech with a minor in nuclear engineering and another minor in environmental engineering. Also did management studies and things like at Harvard, Kennedy School, and University of Tennessee. Um, my first job as a professional was helping design and build a 1,200 megawatt twin unit Limerick nuclear generating station in Pennsylvania. I went on with Bechtel to rise to senior executive levels. I've had some really fun stuff that's just, I'll mention a couple things. Spent 18 months as a White House fellow under Bush 1, working for Dick Cheney, having some oversight of the SDI program there, which is now playing again with us. Um, I started Bechtel's environmental company, which became very profitable. I led the recovery for the Saudi government, Saudi king, during Gulf War One, and helped lead the extinguishing of the fires in Kuwait. I led the privatization of the British nuclear industry for Tony Blair. And I led the recovery for Mississippi for the U.S. government, Haley Barbour, after Katrina. I was one of the senior directors at Los Alamos National Lab. My final job with Bechtel when I retired was I ran Bechtel's global mining business worldwide for about 8 years out of Santiago, Chile. Since then, I failed at retirement, and I'm now working as the CEO of Space Nuclear Power Corp. We're pretty excited about that. Even my wife has been 100% on board. A couple
That's
guys.
important. Very important.
When you've met my wife, she's all in. She's helped me in my career all my life. I wouldn't have gotten where I did without her. It's a great partnership. I gave her a Valentine present this year that in the back of it was a list of all the places we've lived together.
Wow.
28. 28.
Oh my
Uh,
gosh.
why did we start SpaceNukes?
Yeah, how did you
SpaceNukes.
go from, Bechtel, which is a very large company, now you're at a startup company. How did you make that decision and what brought you to SpaceNukes?
Well, you know, your connectivity to people around the world never goes away. And so working inside the Blair administration in the UK with privatizing the nuclear industry, I basically met everybody in the game. And I got a call. They asked me to introduce them to the civilian nuclear power people at Landell. So I did that. And we had some great meetings. They all came over, had some great meals at the house. And I thought that was done and I was going to go back to retirement. And one evening, three guys knocked on the door and said, do you remember us from the meeting with Brits? And I said, sure. And they said, would you help us with the business plan? And the rest is history. I read what they've done. I knew about the Krusty kilopower experiment we'll talk about in a few minutes. But I'm looking at some of the smartest guys in the world asking me to help them. And I was just blown away. And so we created it. In 2019, we became a C Corp. We've been done it, to date on our own backs, and we just worked hard. And that's how we got started. The four founders are now very good friends. We're bringing a fifth guy in that's at the equal level of smarts with us this week. But that's us.
That's exciting, really exciting. And how is nuclear energy attracting so much attention right now? What is the background here? Why we're hearing so much about new companies starting? We're hearing a lot about these big rounds that people are raising, and we're hearing about nuclear energy a lot more as investors.
I'm gonna tell a little tiny story. When I was in high school, it took me three high schools in three countries to graduate. My dad was in the Navy. We bounced all over the world. Um, I was in a high school in DC area, Thomas Jefferson, and so I
Okay.
met with Friends of the Earth and Greenpeace and talked to them. And I said, as a young high school student, the biggest decision you'll make in life is whether you're pro or anti-nuclear. Well, they made the wrong choice. I think the world after this many years and seeing that nobody got hurt at Three Mile Island. Fukushima was bad, but in reality, it produces great power for very little environmental impact. And I think the world is getting more and more comfortable with the topic. And so I think that's the change. I think the whole startup arena is bringing lots to it. It's not easy terrestrially. I mean, Bill Gates, we've worked with him on what he's doing, has been at it 20 years, and he's just now starting to cut metal on his first reactor. But I believe we've got a bit of a renaissance on Earth. We're very focused on space, and I'll explain the difference. But one area is there's a heck of a lot less regulatory issues to be worried with.
Okay, great. Yeah, and you talked about your technology and how it's well suited for space. Have you always spent your career working in the space area, or is that something that started with SpaceNukes?
Funny thing, in Bechtel, you do lots of everything. I've helped with quite a few launch complex. I've worked in the nuclear fuel cycle. I've worked in the environmental cleanup business. I've done the mining business. So you've got to be flexible. I've loved my time with Bechtel. It was what an experience, what a chance to go build some of the biggest things in the world. Our technology is different, and that's what I love about it. The guys, and I'm going to show you this little model. The guys designed and built and tested this while inside the lab in 3 years for $18 million. Prior to that, and they were very frustrated. They're seeing their careers twilighting, and they've never done anything. The last time the US flew a reactor in space was 1967 with SNAP 10A. Our
Wow.
government has spent $20 billion over the last 65 years and has not delivered any hardware. So the guys did it. They built this. This is our reactor. This is the core. This is the rod. These are the heat pipes. We have the Stirlings that this goes to. This is a beryllium reflector. And what we have here is such a simple reactor. It was designed and built and tested, and the assembly of it took 6 hours in the Nevada test site. I'm going to stop there. 6 hours to assemble this. Everything we do is done in a non-nuclear industrial environment until we add the fuel. That means we don't have to spend money on guns, guards, and expensive licensed facilities. We use other people's stuff. But that's what we have. It's got some incredible features to it. Number one is it's a fast spectrum reactor. It's not a light water reactor. It's not a moderated reactor. It's perfect for space. Number two is it's autonomous. I do not need a reactor operator in the game. And so what I'd like to do is to spend anybody that's interested, take a little look at our site, call us and ask us for a short presentation, but our reactor load follows. And number three on our reactor, excuse me, is it can be without any further ground testing, which is the expensive hard part with the regulators. We can grow to megawatts. We want to walk, crawl, walk, run. We've done the crawling with Krusty. The walking is this, and we're working on one right now here. We've got a contract with the U.S. Air Force, AFRL, where we're designing, this is our part. They came to us to look at building a little tiny reactor for them. They keep changing their mind. This is now at 12 kilowatts. This part down here is being built by Lockheed Martin, our partner, and this is supposed to fly in 2029. But this is called Jetson. It's meant to fly in cislunar space. It's nuclear electric propulsion. I'll pause for a minute and let you throw me a question there, Bill.
Yeah, we're getting a lot of questions. So, the thing that's really hard, I think, for investors to get, and I'd be interested to hear your perspective is, I think Bechtel is a wonderful company. Why is Bechtel not innovating and making products like this? Why is it a small startup that is just being formed, working on able to innovate in this area.
Sure. Well, I'd argue with you about Bechtel not being innovative. I think they're extraordinarily so. They lead the
Okay.
world in what they do, but they're an engineering construction company.
Okay.
They have actually a lot of people involved in looking at how do we leave the Earth. They've built some of the biggest space facilities on Earth around the world. They've got a group that's looking at both, space mining as well as lunar habitat. One of the family's kids is involved with something called bricks and mortar. So setting Bechtel aside, I think innovation often starts with a small team with a lot of excitement. Bechtel builds inside their groups, lots of small teams. I did a lot of startups inside there. It was easier for me, Phil. I didn't have to call guys like you and say, help me get some money. I just called Riley Bechtel up and said, I need 20 million bucks, Riley. And he says, okay, show me the plan. And 20 minutes later, we had a deal and we went and did it.
Yeah.
So I'm learning your guys' gig. Apologies if I don't use all the right words. But
You're doing great. You're doing
thank
great.
you. Thank you. But I think that this is going to be a very fast moving game. Can I talk a little bit about the markets?
Would love to hear about it. And I think you can see how interested people are. We're getting a lot of great questions in the chat, but you just keep going. And what Daniel will do at the end, he'll like pull together these questions and start firing them at you.
Good. I'm ready for it.
Yeah.
So first, we see surface power on the moon and Mars. First
Yeah.
for governments, and then for private sector. We're already working on power purchase agreements. We're already talking to people that are interested in doing data centers in space. So that's a huge market, and we think it's going to be fun. We think the first thing that we'll do is land something around 10 kilowatts. We're in discussions with all the guys that have landing capability. Yesterday, we spent a bunch of time with one you all would know. We've also been working with Lockheed Martin with their lander, and we have two or three others that are on the list to go talk to. So one market with multiple customer opportunities, governments and commercial, is surface power. And you have to extend that to the moon and to Mars. We've done work for Elon Musk.
And what do you, just to give people a little bit more details, this might be new for some people. When you have power on the moon, where is that power going?
That power will go where we have groups of people. The moon has 14-day nights, and you have extreme problems with not having power. Nuclear power is going to be critical to not just survive the night, but to actually conquer the night and be able to operate at the night. So it'll go where people are, and we'll probably put our reactors about a kilometer away and run a cable. And our first reactors will be about 10 kilowatts, which is about a small community.
Okay.
And that can power about anything we need. Our Gen 2 reactors, which are a couple of years away, same size, same weight, are 100 kilowatts. And that technology, what the guys have created, is amazing. When you go up in power, rejecting heat's easier. So that's what we'll do there.
How do you get these power units onto the moon? Are you building them there, or are they going up already built?
Well, you've seen the sizes. I mean,
Yeah.
this one is about this big. It's about 2,000 kilograms.
Okay.
So Intuitive Machines has a design ready to land in a few years, and that can handle that weight. We're in discussions. It's kind of fun to be a customer for Lockheed Martin and have them pitch to me as a little tiny company, but they're presenting their lander designs and what they can do. They can handle up to about 3,500 kilograms. They're probably the best. They're a little expensive. We got two others that I don't want to name yet, but that we're talking to. We'll pick the right lander company, and we will go land. But we will build them on Earth. We'll build them in a light industrial facility. We'll add the fuel at the launch site, and we have all the processes to get permits and the safety cases. All that's ready to go.
Okay.
And that way we don't have to build own facilities that have high-class nuclear qualifications with lots of guards and guns. It's a very efficient model. It's very different than how anybody else is doing it.
Okay, great. And then could you talk to us about some of the regulations around transporting your product, about operating your conquering and operating on the moon? What's the regulatory landscape? Are there the same hurdles that so many companies are facing on Earth?
Sitting right behind me in one of the cubicles in our offices is a gentleman by the name of Patrick McClure. You've met him, Phil.
Yeah, amazing
Patrick
gentlemen.
Patrick is probably the world's expert on this topic. He
Okay.
led this effort for Draco, nuclear thermal rocket for the DARPA and NASA program, which is a very hard, complex safety case. We're simple. We're pure. We're uranium. You can touch the uranium. If this was the uranium, I could touch it with my hands until it's turned on.
Okay.
So the regulatory process is defined in a presidential order signed by President Trump in his first term. And it basically requires that you look at, can we cause any harm on Earth? Will there be an incident when you launch your reactor? The answer is our designs could land in water, and because they're fast reactors, because of the geometry we've chosen, they cannot turn on. Number two is even if the rocket exploded and we had fragmentation of our core, there's the difficulty is just going to pick up the bits of uranium, but it's not a threat or a harm to any humans. So we're three orders of magnitude below any the presidential order, any standard. We're already in informal discussions with the regulatory group, the INRSB, that will be doing this evaluation. We're doing it as part of our Jetson is the same reactor we would land on the moon. So we're already have our safety cases already built. We've done all of our criticality analysis. We're ready to go. That helpful? I mean,
That's super helpful. Yeah, everything that you're talking about is very insightful, very thoughtful answers. The what are the other options? You know, when you're talking about surface power on a celestial body on the moon, w why can't we use other why power sources? Why do we have to use nuclear energy? Why do we have to work with a technology that we haven't seen innovation in 60 years? Why aren't we using solar? Why aren't we using wind? Why aren't we using, why is nuclear a good fit here for the use cases you're describing?
well, first, thanks for the plug. This is the first significant nuclear innovation in 60 years.
Yep.
I mean, the American Nuclear Society dedicated an entire journal in 2020 to the work that Dave Poston, Patrick, and Mark did on Krusty and Kilopower. So it's huge. But to answer your question, our first Gen 1 reactors in space in an orbit environment are about the same as solar. It's when you're in near Earth orbit
Yeah.
or near in that realm. It provides some other different help. You don't have to point at the sun. On the moon, you've got a 14-day night. And so people have all sorts of ideas of how they're going to build these tall towers and collect solar when they're on the South Pole. Well, the areas where you can actually do that are very limited. The amount of weight is massive. The studies we've done for Elon Musk show you that we're many, many times better than solar on Mars, especially when you consider dust. It's many, many times more weight that you have to lift to do solar. Elon's all in. He's seen the study we've done for him, and he's going to need it to make fuel for the guys to come home. So it's the same issue on the moon. We're closer to the sun, and when you have sun on your things, great. Have some solar there to give you peaking power, but you can't use wind on the moon. You can't use any sort of generator system. There are some other technologies that might be useful, but as a power density, a weight per kilowatt out, nuclear is going to be the absolute very best. NASA's settled on that. They've gone back and forth, which has been a little bit frustrating between wanting 10 kilowatts or 40 kilowatts or 10 kilowatts. We're ready with 10. 10 will suffice for most of the Artemis programs. All the helium-3 miners we're talking to want to start with 10 or 15 kilowatts. All the other people that are doing development exploration work that we're getting LOIs and PPAs with are looking at the 10 kilowatts as a starter. A couple of years from now, with same size, same weight, we can drop our second generation 100 kilowatt, and in a few years, megawatts.
How
I
do
learned
you think about, when you're describing how big is the opportunity here? Like the way you're describing it, I think you're very excited about the technology. For investors, they're wondering about, how big a market this is, how many units would you sell on the moon, or is it proving out a technology on the moon and then taking that technology to some other much larger markets?
we're currently working. I've got about six market segments that we have identified. I've talked about surface power, and
Yes.
I've talked about the multiple customers there. But let's talk about Golden Dome.
This is a fun topic, my favorite topic.
Golden Dome, and some of the reason I'm hard to reach, Phil, is those guys have figured out the MDA guys, the Missile Defense Agency, and the Space Force have figured out that we're the only company that can put a reactor in space this decade.
Okay.
It's gotten crazy. Yesterday, I've spent 2 hours on the phone with the team that's providing the insight to the guys building the architecture for this new approach. And they're actually flying down here week after next. They wanted to bring 30 guys. I said, no, I mean, I've got room for them. I got a big, I said, I want to bring people here so that have backgrounds in physics and
Yes.
backgrounds in nuclear power.
You could
And
have
so,
over 30 people. That'd be a good party at your house. The bar would be rocking.
yeah, you've not been yet. Phil,
No,
you're
Doug,
welcome.
Doug's telling Doug's telling me a lot of stuff about it.
Okay, well, we have a lot of enjoyment there, but they're excited beyond belief. We've been invited to a second session with them, but Golden Dome needs power in space. There's going to be several components to it. There's going to be a land-based piece of it. That's going to move very fast. But the space part of it, you need sensors. They need to be powered.
Okay.
You need agility to move without regret, because right now there's a lot of tough stuff going on in space.
Okay.
But more important, the big power is needed for defensive weapons to protect us from missiles. We've done a little bit of that in Kwajalein Island. Again, that's an area that Bechtel worked, that I got some background in, as well as my SDI background. But the real opportunity is in space. We
That
we are
area you just mentioned, that's Alaska you were describing, or where's that?
all no Kwajalein is out in the Pacific, and there's
Okay.
a U.S. base there where they do a lot of testing of missile defense systems.
Okay.
But what we'll be working on, and we've got a number of companies that approach us, as well as a couple of national labs, about being the power source. And we've submitted our first submittal to Golden Dome to be the power supplier on for their program. And the traction is growing. It's a lot of fun. I'm
Okay.
not going to stop there. Let me keep going.
I love it.
Um, uh, so one of the jobs of the U.S. Navy on Earth is to keep the seas open for trade. That job in space has been handed to the Space Force. Jetson, this one, is the first demo model of putting a frigate in space to be able to observe and protect U.S. assets in space. It doesn't have any offensive or defensive capability, but it's the beginning of keeping the space open for trade. So there's another whole market that's similar to Golden Dome, but it's way outside of near Earth. So let's talk about the next piece of this. Deep space science. I've got a plaque here, signed by a guy called Alan Stern. This is New Horizons.
Yeah, will you bring it a little bit closer? Yeah, perfect. Wow.
So, so Alan Stern was giving a lecture at University of Florida, and one of my sons is a professor there. Ed went, and he said, "I'm Dr. Phelps, Dr. Stearns. What would it?" And Alan stopped, and he goes, "You're Andy's son." And he goes, "What your dad and your team, their team is doing will change deep space science overnight. We flew past Pluto in a few hours. With your technology, we will go into orbit and study it for years." He said, and JPL has since then created 40 missions they want to fly with our reactor. What they've said to us is they don't want to fly, they won't fly our reactor until somebody else does it first, because a PI for a deep space mission, they get one in a lifetime. So they want to see it work, and then we'll go. I'm not done yet. I'm sorry. Planetary defense.
Okay.
About a month and a half ago, there was a bit of a scare. And we've also done some things where we tried to play with poking at a few asteroids to just try it. This technology with nuclear electric propulsion to gently change the orbit of an asteroid before it's a threat is what it's about. This right here, all by itself, could do that. So I got one more. I'm sorry. Drones. The world is moving to drones. You guys were involved in Andro. We're
Yeah.
watching the change in warfare in Ukraine. Let me give you an idea. Right now, we're building submarines that have to surface every couple days. With our technology, we can give them a submarine that can stay submerged for decades. I don't want to get into speculation on how that could be used, but these would be very small
Right.
and they can be very protective of our Navy. And there's interest there. It's one of the reasons we're keen to get Doug on board because of his Navy background. He'll be a great addition to the team and he can help us pursue that. So that's our market. I'm sorry.
It,
That went on a ways.
and the products that you're making and have tested, are these the products that you'll sell into all those different segments, or are there new products on the horizon that you're working on to sell in these segments?
Um, it's interesting question, and it's not a simple answer. I apologize. This is nuclear. Um, all of our products will be fast reactors using the neutronics, the how the neutrons work inside the reactor, almost identically from 1 kilowatt to megawatts, from near space to deep space to lunar landers to Mars to planetary defense, all use the same basic neutronics that we have the only license to from the work the guys did in the lab. The guys actually we pay for this license. They get royalties back from Los Alamos National Lab because their name is on the patent. Kind of a weird setup. Anyways, so the answer is yes, it's the same technology. The products will vary to fit each requirement. We have a variability on how we produce electricity. With do we use Stirling engines, Brayton engines? On Earth, there's some other technologies that are useful where heat rejection is easy. We will, as we go up in power size, change our fuel type. Right now, for the early ones, we'll use a uranium moly, a solid metal uranium fuel cast at Y12. For our next generation, we'll use uranium nitrate fuel. It's a well-known fuel. We know how to make it. There's some existing at Y12 right now, but probably more needs to be made. As we get higher and higher temperatures, we can even move to CERMAT. But the fundamental technology, the physics of our reactors stay the same all the way through this game. Does that help?
That helps, yeah. The risks around nuclear, like the risk that everyone thinks about, the very hard engineering, the timelines. How does your technology compare to companies that are working in fusion? How does it compare to other companies working in doing fission? How does it compare to maybe think about as other investment opportunities? A lot of people on the call are thinking about whether it's private companies or some of these new public nuclear energy companies. How do y'all think about how different your tech is and how defensible the moats are?
Number one, um, and there's not another startup that has designed, built, and tested their reactor. We're the only ones that have done it. Number two is the work we did with kilopower crusty is extensible to megawatts. So I don't have to build another test facility because that doubles the cost. You got to build a reactor, test it, run it, and once you've run it, it's radioactive as heck. And then you got to dispose of it, and all that costs a lot of money. So it's a big deal that we don't have to do that anymore. We're done. And so that's a big deal. Number two is the technology is ready today. It's been proven. I've got all the data. I've got an entire journal that presents a lot of the data. We're getting 60 to 80 hits a month from the Chinese. My fear is they're going to fly our reactor before we fly our reactor and get a Sputnik moment up there. So I can talk anybody that's got a technical person through all those reasons. Everybody else that's looking at space reactors is doing a moderated approach. We'll be
Yeah.
presenting a paper at the NETS conference in Huntsville in about a month that talks about why moderation is so hard. We cheer them on. We think that it's possible, but we think that because they haven't built and tested a reactor, they're a decade, maybe more behind us. With moderation, you can't go to higher temperatures because your moderator blows all of its hydrogen out. So our generation two puts us another 5 or 6 years ahead of the competition. So we think we've got an incredible product here. I hope we're more successful on terrestrial. The regulatory process on terrestrial, trust me, I've been involved in it, not just in the US, but also in the UK and many other countries. It's tough. It's a tough game. But you've got a lot of transport mechanisms if you have an accident. You've got proliferation issues. You've got all sorts of environmental issues that you need to worry about. In space, there's very little regulation, and its key issue is don't bring it back home hot like the Russians did once. And that,
Right.
for us, that means being above 600 kilometers.
Okay, great. Daniel, Doug, I know we have a lot of great questions. Do you want to start going through some of these great questions we got on in the chat land or that you got on email?
Yeah,
Bring it on.
this was a lot of great questions here. Starting off with, is Asia more amenable to nuclear energy than the US? You kind of touched on in the last point, but yeah.
The answer is yes. One of the most nuclear sophisticated countries in the world is France. I've worked with them and worked with their people. I've helped in the UK keep nuclear in the mix because they have shortages of other fuel sources. Japan went into a bit of a downturn on nuclear after Fukushima. Some of our people were involved in helping with that accident. But you'll see China moving very rapidly towards nuclear. South Korea is moving very rapidly towards nuclear, and they understand the risk to benefit ratio and have done better with it than we have.
Okay. Thank you so much. Next question here is, is the market being addressed by the company? You kind of answered it, but if you want to elaborate here, exclusively extraterrestrial, or is the SMR market also a target?
Um, I'm going to also say that on the U.S., we're about 20% nuclear, but many of our plants are old and we're extending the life on. And I think this bit of a renaissance going on is very cool. Our reactors, when you look at fuel efficiency, probably don't compete well against others. Right now, electricity is between 11 and 16 cents a kilowatt hour on Earth. I expect to be able to sell our power in space in the hundreds of dollars per kilowatt hour. So getting a return on our money, I expect actually when we first start will be about $1,000 a kilowatt hour, which is a heck of a lot cheaper than NASA expects to pay. And so doing that same thing on Earth, it has to be a very unique need for that. And so we're not focused on that. We're truly focused on space. We really think our designs are much better suited for space.
Awesome. And then someone asked, if you could share an update on how Jetson's going and whether or not the partnerships with the primes are helping in that development.
I'll give you the straight answer, like I always do. Working with Lockheed Martin can be challenging. Fortunately, I don't find them daunting. Having worked inside of Bechtel, and this is the benefit of working inside a very big company, you learn how to work through complex organizations. I like Lockheed very much. They're designing the spacecraft. We were asked to bring them in to Jetson because we brought the money. I've got good friends on the Hill. We got $70 million to the Air Force. They peanut buttered it between three companies. We are on schedule and on budget, and we expect to see another $85 million this year to continue the program. And I think that AFRL is very, very happy with us and with Lockheed. Lockheed brought BWXT in because they looked at us as a small company, and they wanted to make sure that A, if we fell over, or B, if they wanted confidence in a technology, because whether they're nuclear aware, they're not deep in nuclear skill sets, and they wanted just a second set. That's all going real well. We're happy, we're executing well, and that's good.
Awesome.
Did I miss some of your question?
No, no, I think that's great. Here's another fun one. Can you explain or discuss the
Cool.
difference?
I'm gonna say something else on that one.
Okay.
Lockheed has the prime. We have a sub. I have an $11 million fixed price task order agreement. And we as a company are well have our head well above water. We're making good money on a FAR contract because it's a fixed task order agreement. And we have no debt, and we feel really good about it. We feel like we're just nailing it on Jetson. We presented 25 different reactor designs to the Air Force for them to choose which one they want. That's the kind of guys we have on the team and the sort of work we're doing. Sorry.
No, no, that's perfect. So next question is, can you discuss the difference in supply chain readiness for your fuel versus Halio? Who would be supplying the uranium? Can you get more of it? Can more of it be readily manufactured? And then is there any competition in other industries for it? I know that was a mouthful, but
No, it's great. So I've worked in the fuel cycle both here and in the UK. I oversaw a lot of the work at Sellafield as part of my job, where they not only, in Springfield, some of their fuel plants, and I helped design and build the centrifuge program up in Portsmouth, Paducah. I had oversight of those facilities. So the fuel cycle is something I feel very good about. If you notice, all the customers have a little link to the US government. So my expectation is early days, we will use fuel that is right now sitting in stockpiles in Oak Ridge, Tennessee at Y-12. They cast the first core for crusty. It's 3 segments, about 30 kilograms of highly enriched uranium. We have designs that can use HALEU. It actually costs more because we downblend the uranium. But we think that's the starter place that we will go. As our reactors get bigger, the complexity of nuclear design means that it's not linear. And so moving to HALEU is easier. But right now, to go for these small reactors, you add 800 kilograms of mass when you go HALEU. I'm not worried about getting fuel. The rest of the supply chain, we use SunPower, who we have great relationships with for Stirlings. We're already working with the companies when we get to be bigger for Brayton engines. We know where we're gonna get our reflectors. Basically, this is not a manufacturing job, it's an assembly job. And when we get to our Gen 2, we actually will print our own core structure. But everything else is like making a car. You buy parts and you put it together. So it's not that hard. The supply chain needs to gear up a bit. If we do Golden Dome, they're going to get a lot of opportunity, and I think they'll gear quickly. Sorry.
We have a question. Someone asked about the moon, the dust on the moon, and Mars, and asked, how do you harden a reactor against these environments?
Sure. Great question. Mars gets to be a little more interesting because we'll use intercoolers, and managing the dust issue there gets more challenging. On the moon, basically, this is a solid state device. The only thing that moves is inside the Stirling engine. We got a little piston that goes back and forth really fast and drives a magnet and produces electricity. And so we will have to make sure we've double encased it, but it's really a solid state device. The core is a solid state device. It requires no operation. We will tweak this up here, this little control rod, maybe once a quarter to make a couple degree difference in the core temperatures. But other than that, all the control is done by how you pull power from the Stirlings, and the Stirlings control the reactor by how much power pull they make. So I'm not worried about the moon at all. Make dust, fine. On Mars, we have a small atmosphere. With intercoolers, that will be a problem we will solve. I wouldn't say we have it solved yet.
Great. Those are all the questions that we have. Andy, I don't know if there's any closing comments that you want to make, but really appreciate all your time. Give you the floor here.
I would expect, and I'm surprised the investors didn't ask it, because Riley Bechtel always asks me, if I get money from you guys, how am I going to pay you back? How are you going to make money out of this? Why is this a good deal? So if we put a reactor on the moon, and let's say we take this 10 kilowatt reactor and put it on the moon, how's that benefit you guys? First, I expect, just like the CLIPS program does, I would expect to be paid as we go from NASA, because this is a critical need they have, and they haven't figured out how to solve it. So I don't know if you've talked to any of the guys that do any of the landers. They basically get paid 90% of their cost, of their contract value, before they launch. When we get to the moon, we will sell electricity. And my expectation is somewhere around $1,000 a kilowatt hour. At 10 kilowatts per reactor, if you do the math, that's $97 million of revenue a year. My total capital cost outlay to put a reactor on the moon is somewhere around $300 million, plus or minus. I'm still haggling I know exactly what my reactor costs. This is all about how much does it cost to launch and land. And I'm talking to 4 companies, so I haven't got to an answer yet, but it's about that. So that's a payback when you consider NASA paying for a lot of the early costs and the ROIs are pretty healthy. So that's one reactor. What do you do? What happens a couple of years later? We'll be at 4 reactors, and we won't be at 100, at 10 kilowatts. We'll be at 100. And so I can imagine myself being at about $2 billion of capital invested on the moon for the different locations we have. I'm very confident that the guys wanting to mine stuff there, either water or helium-3, will pay those prices, because I'm in negotiations with them now. So the returns on investment are big, and even when you get NASA out of the equation. Golden Dome, I didn't come to you guys because I needed money for Golden Dome, because just like Jetson, we were able to do that all on our own nickel, and we're making good money. But I can accelerate our program there. And one of the fun questions we got asked when we presented to the guys at Golden Dome in Huntsville a couple weeks ago, they asked me, how fast can I build 1,000 reactors? My guys kind of stuttered for a minute, but we believe the opportunity there is huge. I know my pricing and my cost of my reactors very, very well. It's south of $100 million, well south. And as I build more, it'll be cheaper. I'm very confident the return on per reactor, and we will scale the company to the demand as it grows, just like a utility doesn't build power plants until there's a customer base that's in the process of being built. We can stay ahead of them, and we can make a lot of money. My intention is to, where I have PPA, sorry for the cough, I have a PPA to the extent I can. All PPA agreements on Earth typically borrow money as opposed to have VC. What I wanted to make sure is for all the investors that we have, the returns are exciting.
Great. Sounds very exciting to us. Really appreciate your time today, Andy. Really, really enjoyed learning about SpaceNukes. Appreciate everyone with the great questions today. Hope you all have a great weekend. Bye-bye.
Take care. Thank you.